questions?
Okay,
Okay, wonderful.
all
All
right,
right,
folks.
folks.
Then
Then
let's
let's
get
get
started
started
with
with
the
the
first
first
module,
module,
Introduction
Introduction
to
to
AWS.
AWS.
So
So
in
in
this
this
module,
module,
we
we
are
are
focusing
focusing
on
on
what are
what are
the
the
different
different
cloud
cloud
deployment
deployment
models,
models,
what are
what
the
are the
benefits of
benefits of
cloud.
cloud.
So
So
throughout
throughout
this
this
course, we
course,
are
we are
going
going
to
to
take an
take an
example
example
of a
of a
coffee
coffee
shop.
shop.
So I
So I
want you
want you
folks to
folks to
imagine
imagine
that
that
you
you
have
have
your
your
you
you
have a
have a
favorite
favorite
coffee
coffee
shop that
shop
you
that you
visit
visit
every
every
other
other
day.
day.
Maybe
Maybe
it's
it's
near
near
your
your
office or
office or
near
near
your
your
house.
house.
So
So
you
you
go
go
there
there
every
every
other
other
day,
day,
you
you
get some
get some
coffee.
coffee.
And
And
so
so
if you
if you
think
think
about it,
about it,
this
this
coffee
coffee
shop
shop
example,
example,
where you
where you
have
have
a
a
customer
customer
and you
and you
have
have a
a barista or
barista or
someone
someone
who's
who's
serving you
serving you
coffee,
coffee,
those
those
that
that
scenario where
scenario
you
where
have
you
a
have a
customer
customer
and
and
barista
barista
scenario, the
scenario, the
customer
customer
goes
goes
and
and
asks for
asks
a
for a
coffee, the
coffee, the
barista
barista
gives you
gives
the
you the
coffee.
coffee.
That
That
can
can
be
be
equated to a
equated to a
client
client
server
server
model.
model.
So
So
where in
where
a
in a
client
client
server
server
model, a
model, a
client
client
makes a
makes a
request
request
and the
and the
server
server
has to
has to
fulfill
fulfill
that
that
request.
request.
So we
So
are
we
going
are
to
going to
use
use
this
this
example
example
of
of
this
this
coffee
coffee
shop. We
shop.
are
We
going
are
to
going to
improve
improve
on this
on this
coffee
coffee
shop,
shop,
bring
bring
in
in
different
different
mechanisms and
mechanisms and
equate
equate
that
that
to
to
different
different
AWS
AWS
services
services
that we'll
that
be
we'll be
using.
using.
In
In
this
this
example,
example,
when we
when we
say a
say a
client
client
makes a
makes a
request
request
and the
and the
server
server
responds
responds
with
with
a
a
reply,
reply,
one of
one
the
of the
AWS
AWS
services you
services
can
you
think
can think
about
about
here
here
is
is
called
called
EC2
EC2
or
or
Elastic
Elastic
Compute
Compute
Cloud.
Cloud.
So
So
this
this
is
is
our
our
virtual
virtual
server
server
or
or
virtual
virtual
machine
machine
on the
on the
cloud.
cloud.
So we
So
will
we will
talk
talk
about
about
this in
this in
detail
detail
in the
in the
coming
coming
module,
module,
but
but
just
just
want to
want to
give you
give you
that
that
introduction.
introduction.
Now,
Now,
what is
what is
cloud
cloud
computing?
computing?
Before
Before
I
I
give you
give you
more
more
details
details
about these
about these
services, let
services,
me
let me
ask you
ask you
folks a
folks a
question.
question.
What
What
is
is
cloud
cloud
computing
computing
according
according
to
to
you?
you?
You
You
can
can
answer
answer
on the
on the
Q&A
Q&A
or you
or
can
you can
answer
answer
on
on
the
the
chat.
chat.
What
What
is
is
cloud
cloud
computing
computing
according to
according to
you?
you?
Related to
Related to
data?
data?
Okay.
Okay.
Virtual
Virtual
storage
storage
system?
system?
Okay.
Okay.
Server
Server
based?
based?
I
I
have
have
few
few
responses
responses
which
which
says
says
cloud
cloud
computing
computing
is
is
available
available
availing
availing
benefits of
benefits
the
of the
cloud
cloud
in
in
terms of
terms of
scalability,
scalability,
performance,
performance,
and you
and
get
you
these
get these
benefits
benefits
rather
rather
than
than
being
being
on
on
premises.
premises.
Yes.
Yes.
On-demand
On-demand
delivery of
delivery of
IT
IT
resources
resources
over
over
the
the
internet
internet
with
with
pay-as-you-go
pay-as-you-go
pricing. I
pricing. I
think
think
that
that
is
is
like the
like the
precise
precise
answer
answer
that you
that you
can
can
look
look
at,
at,
right?
right?
So
So
cloud
cloud
computing is
computing is
nothing but
nothing
it
but it
is
is
IT
IT
services. It
services.
can
It
be
can be
IT
IT
resources
resources
like
like
compute,
compute,
it
it
can
can
be
be
storage, it
storage,
can
it
be
can be
databases.
databases.
So
So
many of
many of
you
you
mentioned
mentioned
different
different
categories.
categories.
Some of
Some
you
of you
mentioned
mentioned
storage,
storage,
some of
some
you
of you
mentioned
mentioned
databases.
databases.
But
But
cloud
cloud
computing
computing
is,
is,
it can
it
be
can be
anything. It
anything.
can
It
be
can be
network, it
network,
can
it
be
can be
storage, it
storage,
can
it
be
can be
databases, it
databases,
can
it
be
can be
analytic
analytic
solutions,
solutions,
it can
it
be
can be
any
any
IT
IT
resources
resources
available to
available
you
to you
on
on
demand
demand
with
with
pay-as-you-go
pay-as-you-go
model.
model.
So it
So
is
it is
on
on
demand
demand
and
and
you
you
don't
don't
have
have
a
a
large
large
upfront
upfront
investment.
investment.
Rather, you
Rather, you
focus
focus
on the
on the
on-demand
on-demand
model
model
where
where
you
you
pay
pay
for
for
what you're
what you're
using
using
and you
and you
use
use
exactly
exactly
what you
what
need,
you need,
right?
right?
So
So
that is
that
what
is
cloud
what cloud
computing is.
computing is all about.
Absolutely.
Absolutely.
So
So
folks who
folks who
mentioned
mentioned
databases or
databases or
storage, you're
storage, you're
absolutely
absolutely
right.
right.
It's
It's
just that
just that
cloud is
cloud is
not
not
just
just
databases or
databases or
storage. It
storage.
can
It
be
can be
much
much
more. It
more.
can
It
be
can be
network, it
network,
can
it
be
can be
compute
compute
as
as
well,
well,
and
and
many
many
other
other
services.
services.
Wonderful.
Wonderful.
Thanks
Thanks
for
for
the
the
answers,
answers,
folks.
folks.
All
All
right.
right.
Now,
Now,
I
I
see a
see a
question
question
on the
on the
Q&A
Q&A
about
about
the
the
content on
content
the
on the
screen.
screen.
So,
So,
folks,
folks,
whatever
whatever
is
is
there on
there
the
on the
screen,
screen,
I
I
am
am
also
also
explicitly
explicitly
going to
going to
read
read
that
that
out. So,
out.
in
So, in
case there
case
is
there is
any
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 issues
issues
with
with
seeing
seeing
what's
what's
there
there
on the
on the
screen,
screen,
I
I
will
will will explicitly also mention what is being displayed, okay? So don't worry about that. Alright. So next we will discuss the different cloud deployment models, and there are three models that you can think about. One is cloud-based, one is on-premise, and one is hybrid. So let's look at these three models. The first one, cloud-based, very basic. Think of this as migrating all your applications to cloud, or think of this as designing everything from the scratch on cloud. So this is a cloud native approach. Everything, all your applications, all your databases, all your storage, everything is on cloud. This is cloud-based model. The second model, on-premises. So this can also be called private cloud. On-premises deployment or private cloud. So private cloud is kind of when companies want to use the benefits of cloud. They want to emulate cloud using virtualization techniques. They want to use resource management tools to get the feel of cloud. But it is actually running on premises itself. It is actually maintained by your corporation or by your organization. That is private cloud. And the last one, hybrid. Hybrid is where you might have a mixed approach. So you might have certain resources, certain applications running on your on-premise data center. You might have certain applications running on the cloud. So think about hospital examples, or think about government applications where there might be some sensitive data which cannot be put outside of their private network. So that data or those databases, they can reside on the on-premise infrastructure, and the rest of it can be moved to cloud. So you have a hybrid approach here, and that is hybrid. So according to your requirements, you can go with which option you want to get started with. And these are the three deployment models that we have. Now, AWS. What you see in front of your screen right now and what I am showing right now is a small snippet of the AWS management console. AWS officially came out as a cloud service provider in 2006 with a wide variety of compute services, storage services, network services, analytics solutions, you name it. And you can access these services via different mechanisms. So you can directly use the console, which is a UI-based interface. You can use CLI, command line interface. You can use SDK, software development kits. If you're a programmer and you want to write programs, you can use SDKs. All these approaches are available for accessing your AWS services. Irrespective of which method you use, these services have APIs, which can be used for creating the service or updating it or modifying it or granting permissions. So all of your console-based approach, CLI, SDK, all of these actually interact with the API calls. Now, we are not going to write any programs in this course, or we are not going to go into a discussion of the development side, but just letting you folks know that these are different approaches that you can have, the CLI, the SDK, as well as the console-based approach. Now, what are the benefits of cloud computing? A lot of you have already mentioned this during the initial discussion, but I'll just quickly go through these benefits once again. The first and foremost is the pricing part, right? Upfront expenses versus variable expenses. If you are deploying something in a physical on-premise data center, then you have to invest in it. You have to invest in the data center, you have to invest in the support personnel, you have to invest in the hardware part of it. You have to expend and you have to invest there. Irrespective of what is your usage, irrespective of what is going to happen some days down the lane, you are still having an upfront expense there. However, on cloud, it is a variable expense. You are not dependent on any data center investment. You are not dependent on buying any physical servers or taking care of the security of the data center or taking care of the cooling. All of these things, you are not having any upfront investments, and it is a pay-as-you-go model, which is one of the primary reasons a lot of you mentioned when we were discussing about cloud, right? So definitely that is one of the benefits that we have. The second one, cost optimization. Now, if you focus on the application versus if you focus on the running of the data center, your results are going to be two different things. If you have to run a data center, you have to have support personnel there, you have to take care of security there, you have to take care of replacement of hardware, you have to take care of maintenance, you have to take care of electricity, cooling, everything. All these operational tasks you have to handle. But on cloud, instead of using a physical data center on cloud, you don't have to worry about who is going to take care of the hardware, who is going to take care of the security, physical security, who is going to take care of the cooling, the electricity. All of this is handled from the service provider side. So you are not spending your effort, your operational overhead on unnecessary activities, but you get to focus on your application, app optimization, database optimization. You are able to focus on what is actually important, which is your business. And the third point, capacity planning. Often what happens in an on-premise deployment or in a physical data center setup, you will have to guess your capacity requirements. Now, you might all remember the time when demonetization happened, and then there was a switch to digital payment platforms, right? Now imagine I own a digital payment application, or I manage a digital payment application. And if I was running this application on premises, and suddenly I get to know that, okay, there is this demonetization that's happening, and people are going to start using my application more, I will not get much of a headway. Maybe 5 hours, 6 hours before the actual event occurs, I'm getting to know about it. Now, I cannot predict this, and I cannot scale up to meet this requirement. If I had to do that, I will have to pre-purchase these servers, and purchasing them, I have to go through all the financial approvals, then I have to talk to the vendors, then I have to get it shipped to my location. It can take at least a couple of weeks. Same thing you move to cloud. I want 10 servers tomorrow. Okay. I want to reduce it to 5 tomorrow. Okay. I want to increase it to 25 day after tomorrow. Okay. I don't have to guess my capacity. I can scale in and I can scale out according to my requirements. And the fourth benefit, economies of scale. If you look at AWS has lots of customers, lots of people already using AWS services, and AWS maintains and purchases these hardwares as a whole, as a bulk. So obviously the economic scale that AWS has is huge. Now what happens is AWS passes this down to the end user as better pricing. So if you go to the internet and if you just search how many times AWS has reduced the price of services, you'll be able to see the price has come down. Service pricing has come down multiple times because of this economies of scale. So whatever economic scale AWS has, AWS is able to pass it down to the end user. And then speed and agility. So earlier I was talking about capacity planning, and same thing applies to speed and agility. I don't have to wait for weeks. I don't have to wait for a long time to go through financial approvals, to go through the vendors and get my new resources, new hardware, if I want to get started with a new project. I don't have to worry about how to procure this, how to take care of the capacity part, how long will it take. I don't have to worry about any of that. Within a matter of a few minutes, I can spin up servers, I can spin up, let's say, load balancers, I can create databases, and I can just go ahead with my development. And another very important point, the global presence. If you look at AWS global infrastructure, which we'll go into details in the coming modules, you will see that there are so many geographical locations that you can go and deploy your workloads into. Let's say, for example, if you start with India, we have Mumbai, we have Hyderabad, we have different regions available. Now, tomorrow I want to expand my business presence or my applications. I want to make it accessible for people outside of India. I don't have to physically go to a particular country. I don't have to partner with anyone there. I don't have to go and invest anything and build a data center in a different country, but I can just use the AWS regions available in the different geographical locations, and I can just get started. So you can go global in a matter of a few minutes, and which is another very major advantage of AWS. So these are few benefits. Definitely you will find many more, but if you look at the core reasons why a lot of customers, a lot of users take advantage, these are the benefits that you will find. And like I said, there are different AWS service categories available, and throughout the course, we will look at few of them. We'll look at networking, like we will look at VPC, which is a private network on AWS. We'll look at few database examples like RDS, Relational Database Service, DynamoDB. We'll look at those examples. We'll look at storage examples like Simple Storage Service. We'll look at EFS. We look at block storage options. We look at different compute options. We look at different security governance options. So there are different categories that are available, but we'll just be looking at some of the core service categories throughout the course. And when you do the digital training later on in Skill Builder, you will have a much deeper understanding about these services as well. So that brings us to the end of the first module, and just wanted to take some time to see if there are any questions before we go through the knowledge check. Folks, if you're not able to see the screen, can you please re-log in again? I see one person just saying, just mentioned that it's not visible on the screen. Can you please re-log in? Okay. All right. So folks, what we're going to do now is we are going to have knowledge check questions, which are nothing but a bunch of question answer statements. I will show you a question, show you multiple answers to it. I will again reiterate all the answers given. You just have to choose the correct answer and put that in the chat. Okay? Yes, I will summarize all of these in the end after I finish the knowledge check. Okay? So folks, let's first go with the first knowledge check question. I will read the question. I will give all the options, and you can just answer the correct one in the chat or in the Q&A. Question 1. What is cloud computing? That is a question. The options are option A, backing up files that are stored on desktop and mobile devices to prevent data loss. Option B, deploying applications that are connected to an on-premises infrastructure. Option C, using on-demand delivery of IT resources and applications through the internet. And option D, running code without needing to manage or provision servers. So you can just select A, B, C or D, and you can put the answer in the chat. Folks who joined a little late, please enable the closed captions option in WebEx so you can see the audio highlights as well. It is there in the left hand side of your WebEx panel. Okay. Okay. We are just waiting for another few seconds. Okay. So everyone is unanimously agreed the correct answer is C. Using on-demand delivery of IT resources. IT resources can be anything. It can be compute, it can be network, it can be storage, analytics, it can be anything. And applications through the internet, which is what we call cloud computing. One more question. What is another name for on-premise deployment? And the options are A, cloud-based application, B, hybrid deployment, C, private cloud deployment, and D, AWS cloud. Giving everyone a few seconds. Okay, we have few responses. This time it's mixed response. Okay, so if you remember, we talked about the three deployment models which you can have. First, this cloud-based deployment, where either you migrate everything to cloud or you start building on cloud, so native cloud deployments. The second option that we discussed was called private cloud, or it is also on-premises deployment. It is another name for you using virtualization techniques or resource management tools to emulate the feeling of being on cloud, but you're actually running everything on premises. So that is private cloud. So the correct answer here is option C, which is private cloud. And there is one more option, which is option D. There's one more category, which is the third category, which is hybrid deployment, where you have certain services on premises, certain services or certain applications on cloud. So these are three options that we have. Yes. So thank you folks for answering those questions. So just to give you a summary of what we discussed so far, this was an introduction to cloud. So we looked at what is cloud, what are the benefits of cloud, like the pricing benefits. We looked at the scalability. We looked at the on-demand availability. We looked at the global presence, going global in a matter of a few minutes. The speed and agility that you get to start your deployment works. So all of those benefits we discussed. And we also discussed the different cloud deployment models. One is your cloud-based deployment, which is completely cloud. Either you migrate everything to cloud or you start natively from cloud. Second is private cloud or on-premises, where you use virtualization techniques or resource management tools to get the feel of cloud. And the third one is hybrid, where you have certain applications running on cloud and certain applications running on premises. So these are the things that we discussed in this particular module. Rahul, I hope that's clear. I see a question. Yeah, on-premises is where, or it's another name for private cloud, where you use virtualization techniques to get the feel of cloud, but it's not actually a public cloud. It is your organization managing it. Any other questions, folks? Okay. So, folks, we will be taking small 10 minutes break every now and then, so that we allow everyone some breathing space and they get some time to walk around. So we're going to take a small 10-minute break. We will be back by 10 a.m. So roughly 12 minutes you have. We will be back by 10 a.m. So please use this time to go grab a cup of coffee and then feel refreshed and come back. Okay? I'll just put up the timer. All right, folks, I hope you're all back here. A quick confirmation on the chat would be really wonderful. Perfect. Thank you so much. I do see a couple of repeat questions from participants. Folks, please continue to use the chat as well as the Q&A section because we cannot unmute all of you. You will have to rely on these two platforms, the chat as well as the Q&A, to ask questions. And when you ask questions, especially on the Q&A, please don't ask it just to me. Please ask to Amit as well as myself, because if you just direct it to me, I'll be delivering the session and I may not get the chance to look at that. So please address it to both myself as well as Amit, okay? And a couple of other questions. PPTs and recordings will not be provided. Instead of that, if there are any relevant materials, we will share the necessary white papers. We will share the necessary documentations which you can go through. And these documentations, you can read it using your screen reader. That was another question that was asked. Is it screen reader friendly? Obviously, the videos that you see right now, it may not be screen reader friendly, but your documentations which you can read through, they will be screen reader friendly. Instead, I will also be explaining whatever you have on the slides, whatever I'm showing on the screen. I will be explicitly explaining what is being shown. If there is a picture, I will explain that as well. A couple of other questions about jobs for candidates who have visual or auditory issues. That is definitely not a problem. That is the whole reason why we are here. We are here to empower you, to help you understand about cloud. So during the introduction, you might have heard from the different panelists on why cloud and why it is important that we should learn about it. But also I talked about what will happen as the next phase. So once this training course is done, I will help you get registered with our learning platform, which is called Skill Builder. And there you will complete the whole digital version of this particular course. So it will act like a refresher, and once you finish that, you will be eligible for a Credly badge. And then using that badge, especially the women candidates, you can get discount vouchers for your AWS certification. You will be eligible for the job fairs which are being conducted in collaboration with Aspire for Her. So all of those will definitely be the next steps. I will help you out with the registration process towards the end. And folks, one more request again, just reiterating, please enable closed captions so that you can also have the audio highlights in the form of text available. You can see that on the left-hand side of your WebEx panel. Okay? All right. So I think that clears out all of the questions. Let's start with module 2. This module is going to talk to you about what are the different compute services that AWS has, and we will focus primarily on one service which is called Amazon Elastic Compute Cloud, or in short you will hear the term EC2. Elastic Compute Cloud, in short, it is EC2. So Amazon EC2. We'll talk about what is EC2, what are the different types of EC2 instances, what are the billing options, how does scaling work, how does load balancing work, what are the other queuing and notification services, all of that we will look at. So again, let's go back to the coffee shop example we discussed today morning, right? We were talking about a customer going to the coffee shop, asking the barista for a coffee, and the barista giving you the coffee. So this is a client-server model I was equating this to, right? So this barista, the person who is taking your order, giving you the result back. Same way, client sending a request, server sending a response back. That server can be your Amazon Elastic Compute Cloud or Amazon EC2. So going forward, if you hear EC2, just understand it's the shortened version of Elastic Compute Cloud. So what is EC2? It is a virtual machine or a virtual server. So just like how you have physical servers on your on-premise infrastructures, or just like how you have physical laptops, physical desktop machines, instead of that, a virtual machine or a virtual server is called Amazon EC2. And this is completely your virtual machine, meaning only the physical infrastructure is managed by AWS, but you can decide what kind of machine do you want, what kind of OS do you want. Is it Mac? Is it Linux? Is it Windows? You can decide that. You can decide what applications to install. You can decide who gets to access it, the firewalls, everything you can decide from your side. And you will pay for when you're using it. So if you use this server for, let's say, 2 hours, you pay for 2 hours. If you shut it down and then you don't use it, you don't pay for it. So it is an on-demand option also available with EC2. So how this works is, all you need to do is you use the console or the CLI or the SDK, which as we mentioned earlier, to launch an EC2 instance. So instead of a server, we call it an EC2 instance. So whenever you hear the term EC2 instance, understand we are talking about a server, an EC2 server. So it is an EC2 instance. So you launch an instance. When you launch an instance, you can give details like I said, what OS, what is the memory, what is the CPU that you require, network performance, storage, what kind of network, all of these details you can specify. And then sure. And then you can launch the instance. Once you launch the instance, you can connect to the instance. Now, how do you want to connect to the instance? Multiple options are there. If you want, you can use SSH. If you want, you can use RDP based on if it's a Windows machine. Or different other tools are available using which you can connect to the instance. And then you can use this just like any other server. You want to install databases on it. You want to install some website on it. You want to have some storage done on it. Whatever you want, you can use this as your own server. So this is what EC2 is all about. Now, when you go through the Cloud Practitioner digital course that I was explaining earlier, you will get a deeper understanding. Here we are just giving you an introduction to what the service is. We are not here to go dive deep into the service, but when you go through the digital course, you will have a dive deep understanding of this. Now, when you create an EC2 server or an EC2 instance, you can decide what is the instance type. Now, what do you mean by instance type? Let's say you're going to a shop and you're buying a laptop. When you're buying a laptop, you can tell them what kind of laptop you want, right? For example, if I'm using it for gaming purposes, then I will require maybe a good graphics card. I will require maybe GPU-based machines. If I'm using it for everyday office purposes, maybe I'm not doing any development work, just sending emails, receiving emails, or just Excel and these kind of workloads, then a normal machine is fine for me. If I plan to run something like high performance computing, then I will require a compute intensive machine. So similarly, when you go and you create an EC2 instance, you can decide what kind of instance do you want. And this is called the instance type. There are multiple instance types available. The first one is called general purpose. General purpose, from the name itself you can understand, it says general. Meaning, this is for any everyday workloads. You want an application server, you want a small database, everyday workloads where you want a mix of compute, you want a mix of memory, you want a mix of networking resources, you will go with general purpose. The second category is called compute optimized. So again, from the name itself, you can understand this is for compute-bound applications. Let's say gaming servers, or you're running some high-performance computing. You have some compute-intensive server requirements. Then you will go with compute-optimized machines. The third one, memory optimized. Again, from the name, it's very clear. Here, the focus is more on the memory rather than on the compute. So think about an in-memory database or an in-memory cache that you want to create, where the focus is on the memory rather than on anything else. Then you will go with memory optimized. The fourth one, accelerated computing. So this is where you have things like floating point calculations, graphics processing, data pattern matching, gaming, 3D rendering. In these kind of situations where you're looking for hardware accelerators, or you're looking for GPU based machines, then you have to go with accelerated computing. And the last one, storage optimized. Here, the focus is on getting a low latency read-write access to the local storage. So let's say, for example, you have some log processing to be done, and the logs are stored in your local storage. Now, from your machine, you need to have low latency input-output to that particular storage device to help with log processing. This is a storage optimized machine. So Amit will also be sharing the document for the different instance types. We are just giving you an introduction to the different instance types, but this document will go dive deep into the different categories. What are the different types available? What are the different processors available? What are the network options available? All of that you will get in the details in the documentation that will be shared by Amit. But this is just to help you understand that there are primarily 5 instance types: general purpose, compute optimized, memory optimized, and accelerated computing, finally storage optimized. Okay, so these are the different instance types. Alright, so how do you pay for this? What is the EC2 pricing? Let's look at that next. There are different pricing options. Yes, I do see a lot of pricing questions coming in. Let's discuss that next. There are different pricing options available. The first one is called on-demand pricing. On-demand, from the name itself, you can understand. You use, you pay for it. I use it for 2 hours, I pay for 2 hours. I use it for 5 hours, I pay for 5 hours. So there is no upfront investment, there is no upfront commitment. Whatever you use, you pay for that, which is called on-demand. This is where you cannot predict your requirements. Maybe today you require a server for 2 hours, tomorrow you require it for 5 hours, day after you don't use it at all. So on-demand. Then comes spot. Spot pricing is where, out of this on-demand pool that AWS has, unused capacity goes into the spot pricing. Now here what happens is, spot instances, if you pay via spot pricing, it is very, very less or low price compared to the on-demand. There will be a price that is fixed, a market price will be there. You pay for the spot server, spot instance, you get the machine and you run your workloads on it. Now the question would be then, why can't everyone just use that, right? You can, but there is a thing to notice here. In spot instances, whenever AWS requires the capacity back, so remember I told you this is taken from the on-demand capacity, unused capacity, right? So whenever AWS requires this capacity back, AWS will give you a 2-minute warning, a termination notice, and then the spot instance can be taken away from you. So during that 2 minutes, you can save your logs or you can save anything that you want to save, but it can be interrupted. So the idea behind the spot instance is, you are okay with the interruption, you are okay with the server being taken away. So running some batch workloads or some workloads where it is okay to have an interruption, you can go with spot instances because the pricing is very, very low compared to the on-demand. However, there may be interruptions because it is taken from the on-demand pool. Okay. Then comes reserved versus savings plan. Okay, reserved instances are where you go and tell AWS that you are expecting to use this particular server for, let's say, a 1 year or a 3-year period. So you are giving a commitment to AWS saying that you will be using this server for a particular period of time, 1 or 3 years is the time period, and because of the reservation, you get a better pricing as well. That is called a reserved instance. Then comes compute savings plan. Compute savings plan is also a kind of reservation, but it is not based on a particular instance type, or it is not just based on EC2. You can have a compute savings plan where you make a commitment on the amount of usage. Let's say, for example, you say that you will use $10 worth of compute per hour. Now, how do you want to use that $10 worth of compute? You want to use it on EC2? You can. You want to use it on other compute solutions, like we have a serverless solution called Lambda? You can. There are container options like Fargate, you can use it there. So compute savings plan gives you that flexibility where you are given a commitment about the usage, and again it is a 1 or 3 year period, but rather than saying a particular server, you're saying that this is the amount of compute I am expecting to use, and it can be taken from your EC2 or any of the other supported computing services. That is a compute savings plan. So these 4 categories are what contributes to your pricing. One is on demand, spot, compute savings, as well as reserved instances. And Amit has also shared a documentation on the spot instances, because we have few questions about spot instances. Please make a note of that. Now, one more thing that can add to this pricing is the dedicated computing. Now, what do you mean by dedicated computing? When you run an EC2 instance, usually when you run an EC2 instance, I told you it's a virtual machine. It runs on physical host, right? There will be a physical server, and on that physical server, you will have multiple virtual machines running. Obviously, they are all isolated; they cannot talk to each other, but there will be multiple virtual machines running. So these virtual machines, by default, they follow a shared tenancy. Shared tenancy. Now, what does this mean when we say shared tenancy? It means that on the same underlying physical hardware, multiple EC2 instances can be created, and they can belong to different AWS accounts or different customers. Different AWS accounts or different customers. They are isolated, they cannot talk to each other, but this is the tenancy. Now, certain situations, like for example, you have a compliance requirement. If you take medical applications into consideration, let's say a regulatory compliance like HIPAA compliance and all, let's say there is a compliance requirement which says you cannot have a shared tenancy, meaning you cannot share the underlying hardware. Then you can go with an option called dedicated instance. Here what happens is, the physical server where the EC2 instance is launched on, that server will only have your account instances. It will not have any other AWS account instances, which is called dedicated instance. So obviously this can also be a contributing factor to your AWS, the pricing that you pay. So that was dedicated instance, primarily used for compliance purposes. Then we have dedicated host. Now, why dedicated host? Now, one more thing that you have to understand is, whenever you have an EC2 instance which is running on a physical, obviously it's on a physical hardware. Now, if you stop this EC2 instance, you can start it, you can stop it. It's an on-demand requirement, right? You can start it, you can stop it. When you stop your EC2 instance and you start it again, just like how you switch on switch and switch off your laptop or your computer. When you start it again, this EC2 instance will move to a different underlying hardware, different physical server. So the physical host, the underlying host of the server can change, of the EC2 can change. However, in certain applications, if you take licensing requirements, certain licenses, they will be dependent on the socket, or they will be dependent on the OS of the physical server. Now, if the server keeps changing like this, these licensing softwares will have problems. So in that situation, you go with the second approach, which is called dedicated host. Now, in dedicated host, what happens is that entire physical server is for you. You start the EC2, you stop the EC2, it doesn't matter, it is still going to be that server. So the difference between dedicated instance and dedicated host is that in dedicated instance, the underlying hardware can change. Each time you stop and start, it can change the underlying hardware. However, whichever hardware it falls on, when I say hardware, I'm talking about the physical server. Whichever physical server it falls under, it will only have that particular AWS account EC2 instances. It will not be shared. That is dedicated instance used for compliance purposes. Dedicated host, on the other hand, the physical server itself is fixed. It is dedicated usually for licensing purposes. But these all are contributing factors to your EC2 pricing. Okay. Alright, let me quickly check for any questions. So there is a question about the network. So the network, Ram Yadav, to answer that question, see, what you are concerned about on cloud is a private network called VPC, which we will discuss in a bit. That VPC will be the same, but how it is handled in the underlying hardware, that physical hardware is what I mean, it will change in dedicated instance. Okay. I think we have few documentations from Amit as well. You can please keep those documentations with you. Alright, so I hope EC2 is clear. EC2 is nothing but it's a virtual server or a virtual machine. This machine is your machine. You can decide what you want to install on it. You can decide what applications you want to run on it. All of this you can decide. And you have different instance types available, remember, based on requirements: compute optimized, storage optimized, memory optimized, general purpose, accelerated computing. Different types are available, and we also discuss the different pricing options. There are again few questions about screen reader friendliness of the documentations. A few of them are in the PDFs, if you might look at them, they may not be. So if you see white papers, they may not be. But the others should be screen reader friendly. Okay. Now let's move on to auto scaling. So remember we discussed in the beginning, we talked about the advantages of cloud, and we discussed how scale in and scale out was one of the major advantages, right? So let's talk about that. Again, come back to the coffee shop example. Let's say today is a very slow day. Not many people are coming to the coffee shop. The 2 or 3 baristas in the coffee shop can handle the demand. Now tomorrow there is a higher demand and we need more baristas to take care of the load. You will have to somehow increase the number of baristas at the counter. So, do you go and on that day you see a higher demand in the number of customers? Do you go and you employ more people, or do you take care of it beforehand? No, that is a problem for you, right? Think about the same thing with EC2. It is a server, it is an instance. Now, today one server might be enough for you. Tomorrow maybe you want 2. Day after tomorrow you want 10. 3 days, 4 days later you want 5. You want to increase and you want to reduce the number of servers. This is where, instead of manually doing it, you can use a feature which is called EC2 auto scaling. Now in EC2 auto scaling, what happens is, you can decide what is the minimum capacity that you want, meaning when you have least load, how many servers do you want? You can decide what is the maximum capacity that you want, meaning when you have peak load, maximum number of customers and usage, what is the capacity that you require. And if you want, you can also give one more value which is called desired. So minimum, maximum and desired. Desired is at this point in time, how many do you require? How many servers do you require? Now based on this, you can scale in. Scale in meaning reduce the number of servers, or scale out meaning increase the number of servers according to your requirements. When I say according to your requirements, It can be based on CPU utilization, for example. If, let's say, if my CPU exceeds 80%, I want to increase the number of servers. If my CPU goes below 20%, I want to reduce the number of servers. All of this is possible. And this is called EC2 auto scaling. Now, the second feature or second service that I want to talk to you about is called elastic load balancing or ELB. Elastic load balancing or ELB. Now let's go back to the coffee shop example. So here in the slide, what you see is two different workloads on the coffee shop. One is where you have two baristas. One barista is getting 3 customers and another barista is just getting 1 customer. Now this is an unbalanced workload where one person is doing too much work and the other person is not doing enough work, right? So now to balance it out, we need to ensure that both the people, in this case both the baristas, they get equal number of customers. 2 and 2 or 3 and 3. We need to ensure that. Now bring that into AWS scenario, bring that into EC2. If you have multiple EC2 instances, we talked about how to scale them. We talked about how to increase and reduce the number of servers. But how do you ensure that all of these servers are getting traffic evenly? When a traffic or when a customer talks to your website endpoint, how do you ensure that that traffic is redirected to the right backend server? That is called elastic load balancing. So ELB or elastic load balancing, in short it's called ELB, it can help you do this. So what happens is you can create an elastic load balancing ELB in AWS, and then you can connect these servers, these EC2 instances behind the load balancer. And now what happens is the load balancer will give you an endpoint. So think of it like a DNS endpoint. So your customers will connect to the endpoint, which is the load balancer, and the load balancer will decide, should I send the traffic to EC2 1, should I send it to EC2 2, 3, 4, etc. And you can have rules to decide which EC2 instance to go through and which port to listen to, which protocol to listen to. All of this is possible with your elastic load balancing. So now combine these two. We have auto scaling and we have load balancing. If you combine these two, you are going to get both load balancing capabilities as well as scalability. So the load balancer will be the one which is taking the traffic, and the servers will be connected by the load balancer based on the rules that you specify. So the load balancer will handle that, and auto scaling will handle the number of servers. If there is high traffic, increasing the number of servers. If there is low traffic, reducing the number of servers according to what you define will be handled by auto scaling. Sure, Ranjit. I think that could also be a network delay. So just to recap, folks, we talked about two services, elastic load balancing or ELB and EC2 auto scaling. ELB is used to balance load to the backend servers by connecting the customer or connecting the traffic to the less used or less traffic used servers, so that you have a even distribution of traffic to the backend servers. Auto scaling, on the other hand, is a service or a feature which is used to increase or reduce the number of EC2 instances that you have. You can increase it or you can reduce it. There is a question on the chat. Both ELB and scaling are AWS or user driven. So the service itself is managed by AWS. For example, if you take ELB, the availability and fault tolerance, all of that, it is AWS's responsibility. However, the configuration part, deciding which port to listen to, deciding which protocol to listen to, or if you take auto scaling, for example, deciding what is the minimum capacity, what is the maximum capacity, deciding when do you want to scale. All of that is user driven. So you control it, but like I said, the availability of the services like ELB and all is handled by AWS. So it is definitely user driven in terms of the configuration, where it should be, which network it should be, how it should run. That is completely your discretion. Okay. Alright, so folks, let's do a quick game activity. I'm going to read out certain statements and I want you folks to type out in the chat whether this falls under load balancing or auto scaling. So if it is load balancing, you can type ELB or just type E, that's fine, you don't have to type the whole thing. E, you can type E. If it is auto scaling, type A. If it is load balancing, please type the letter E in the chat. If it is auto scaling, please type the letter A in the chat. Okay? First statement. Removing unneeded Amazon EC2 instances when demand is low. Is this auto scaling or is this load balancing? Okay, we have few responses. Let's wait for the others. Okay, so the answer is this is an auto scaling feature. Second one, adding a second Amazon EC2 instance during an online store's popular sale. If it is auto scaling, please type A. If it is load balancing, type E. Again, repeating the question, adding a second EC2 instance during a sale. Compare this with the previous statement. Previous statement we discussed removing an EC2 instance when demand is low. Here they are saying that there is a sale, meaning the demand is high. We are adding an EC2 instance when the demand is high. So is that a feature of auto scaling or is it a feature of load balancing? Okay, so folks who are confused, anytime you think about increasing or reducing the number of servers, another term for this is called horizontal scaling, meaning you are increasing the number of servers or you are reducing the number of servers. In both these situations, this is scaling. It is not load balancing. Load balancing is where you take the traffic, or rather the ELB takes the traffic, sends it to one of the packets, balances the load to one of the packets. It cannot increase or reduce the number of servers. To increase or reduce the number of servers, we need auto scaling. So, the correct answer is auto scaling. Third statement, distributing a workload across several Amazon EC2 instances. think this everyone has the correct answer. When you say distribute traffic or distribute workload, that is the work of a load balancer. Absolutely right. It is ELB. Fourth statement. Ensures that no single EC2 instance has to carry the full workload on its own. Again, I don't think there is any confusion here. We are talking about traffic balancing, which is taken care of by, yes, it is ELB or load balancing. Fifth statement. Automatically adjusting the number of EC2 instances to match demand. Again, here we are talking about increasing or reducing the number of servers according to demand, which is scaling. So, correct answer is auto scaling. Last point. Providing a single point of contact for traffic into an auto scaling group. So when we discussed load balancing, we said that you get an endpoint using which customers can connect to, and then the load balancer will redirect traffic to the different servers. So here, correct answer is ELB. Alright. So I'm just going to check the Q&A if there are any questions for me. And if you have any further questions on auto scaling or load balancing, do let me know. The digital course will cover this in much more detail. Okay, so sure. Sixth point, it says providing single point of contact. So imagine you have 5 EC2 instances. Now each EC2 instance will have its own IP address. So we don't expect as a customer that they should know all the IP addresses, right? Instead what happens is we will be sharing the load balancer's endpoint. So you have your load balancer. Load balancer is then connected to your EC2 instances, and this load balancer can give you an endpoint. So think of it as a DNS endpoint. Right? So a customer will connect to this DNS endpoint, which is a single point of contact. What happens behind the scene is not visible to the customer. That's it. Okay? Alright, folks. So we are going at this pace because we want to make sure that the closed captions are getting generated. We want to make sure the interpreter is also able to let you folks know what is happening. So we are maintaining a particular pace, folks. So I hope everyone is okay with this. And again, just reiterating, we are not. Just give me a minute, folks. Yeah, so we are not here to understand dive deep about a particular service. Rather, this is an introduction session that we have. Okay. Moving on to the next discussion, messaging services. Now, you may have heard about the two different types of application architecture. One is called monolithic and one is called a microservice based setup. So, what is the difference between these two types of architectures? In a monolithic architecture or application, all the different components are tightly wound together. What do you mean by that? Let's say you are using a forum application where you can ask questions, you can post answers to those questions. Now imagine if this is built as a monolithic application. Now what will happen is each component will be dependent on the other, meaning if one component fails, it will affect everything else. If you want to scale one component, you cannot do that. You have to scale everything. If you want to update the code of a component, you cannot do that. You have to update the whole thing, test it. So there is a lot of tight coupling. It's called tight coupled architectures where one component will be dependent on the other components. So to make developers' life easier as well as to get availability, reliability, scalability, now we go with microservice based setups. So consider the same forum application. Here you identify the core components. Okay, so imagine the component called user. Imagine there is a component called topic as well as messages. These are the core components I have identified as a developer. Now, I will create separate services for each of these components and then I will link them together so that they can be independently scaled, they can be independently deployed, and if one fails, it will not affect the other. This is what is microservices. So here, this feature of keeping them separate is called decoupling or loosely coupled architectures. And for this, we have certain services that can help you, and we are going to look at those services. One of the services which you can use here is called Amazon Simple Notification Service or SNS. And this service is a push notification service. So think about the coffee shop example again. I am a regular customer who goes to the coffee shop. So I have a VIP pass. I get special offers, special discounts, and there are other customers like me who go to the coffee shop. Now, the coffee shop owner has decided that they will share these offers, coupons with these VIP customers via SMS. Now, you can't expect the coffee shop owner to sit and send messages to each and every one person, right? You cannot. Instead of that, what they will do is, they will use the service SNS and then create something called a topic. Now, as the owner, I will send the message to this topic, and whoever is subscribed to this topic, it can be email IDs, it can be mobile numbers, it can be other AWS services like Lambda functions. Whoever is subscribed to this topic, they will all get a message. So for example, if I send a message saying 50% off on Monday, to this particular topic, whichever email IDs, whichever mobile numbers are subscribed to this topic, they will get the same message. And this is what is SNS or Simple Notification Service. So it is a publisher subscriber model. A publisher can publish messages to the topic. Whoever is listening in as a subscriber, they will get those messages. So makes the coffee shop owner's life easy. The second service that we have for decoupling is called SQS or Amazon Simple Queue Service. This is a messaging service. So what do you mean by a messaging service? Let's go back to our coffee shop example. Customer comes to the shop, gives an order to the barista. Barista talks to the cashier in this case. Cashier talks to the barista. Barista gets you the order. This is the process. Now what if there are 10 customers, 20 customers, 30 customers? There is a queue. How do you maintain this queue of orders? This is where Simple Queue Service or SQS comes into picture. SQS is used to create a queue. Whatever messages. So in our case, the order is a message. Customer 1, 2, 3, etc. All these orders are messages. These messages go into the queue and they remain in the queue. And whenever the barista or the chef gets some time, they will act on each of these messages one by one. Now, convert this into a real world example. You place an order, let's say on an online website. These order messages go into the queue. The backend servers, whenever they get some time, they will take one message from this and they will process it. So even if there are large number of customers, it's okay. The messages will stay in the queue. That is what the queue is, and this is what SQS is used for. Alright? Any questions, folks? Okay, there is a question about Lambda which we are going to talk about. So serverless. Let's talk about serverless. Now, you can think about computing as two kinds, server-based and serverless. When you say server-based on cloud, you are definitely not managing any physical servers. Rather, you are managing virtual servers. And these virtual servers, like EC2 instances, you still have to decide what kind of operating system, what type, instance type you have to decide, what network, what storage. You have to handle the starting and stopping of the server. You have to do updates on the server. So this is something that you are still managing. And this is server-based computing. Even though it is a virtual server, you still manage the virtual server. So to make your life easier, instead of this, you can go with serverless computing. In serverless, you only worry about your code. Where it is running, how is it running, who manages the infrastructure, starting, stopping. You don't have to worry about anything. You just worry about the application code. And that service is called AWS Lambda. Lambda is a serverless compute solution where you can bring your code, just bring your code. Don't worry about where it is running, or who is going to manage the underlying infrastructure. Should I start any server, stop any server? Don't have to worry about that. Don't have to worry about paying for when I am not using it. What do I mean by paying for when I am not using it? If I was using my EC2 instance for 5 hours, it was running for 5 hours, and if I have only 2 requests in those 5 hours, I still will have to pay for 5 hours. In Lambda, if I have 2 requests, I pay for 2 requests. I don't pay for any idle time. So serverless computing means I don't have to worry about any details of the server, including where it is running, how it is running, idle time payments. I don't have to worry about starting something, stopping something, upgrades, patching, nothing. Just have to worry about my code. All I need to do, upload the code to Lambda, call the code, or trigger the code, or invoke the code, and the code will run, and you pay for only that particular request, and this is what Lambda does. There is a question on the chat. It says serverless is no storage space. Serverless, to answer that question, serverless can be storage, it can be compute, it can be databases. The idea is you don't manage the virtual server. So if you consider EC2, you still have to manage the virtual server, right? Like which OS, updates, all of that you have to manage. In Lambda, you don't have to manage that. Or if you consider serverless storage solutions like S3, you don't have to manage creating of a particular storage device, how much space it is going to take. So you don't have to manage anything to do with the virtual aspects as well. You just bring your code. That is what serverless compute is all about. Okay, so folks, just to recap, in compute we have discussed 2 services, EC2, which is virtual machine or virtual server, and Lambda, which is the serverless compute. The third one we are going to talk about is containers. Again, folks, this is just an introduction to containers. When you go through the digital course, you will have more deep understanding. Now, how does container differ from virtual machine? If you look at the architecture of a virtual machine versus a container, containers, you can create multiple containers where you package your code, your dependencies and everything into a container image. And that container image you can deploy and run as a container. And the advantage is it is much more faster to create as well as to delete. So to spin up and spin down, containers are easier and faster. So it is also portable, meaning you create a container for your test environment, you want to move it to a dev environment, prod environment, it is portable as well. And for running containers on AWS, there are 2 orchestration solutions available. One is called ECS, or Amazon Elastic Container Service. Short form is Amazon ECS. So this lets you run Docker containers on AWS, or manage the containers, how it is running, the scalability, everything can be managed using ECS. Another option is Amazon Elastic Kubernetes Service, or in short, EKS. Now the difference is, if you want to use Kubernetes, people who have used containers, they might be familiar with this term called Kubernetes. It is an open source container orchestration platform. And if you want to support Kubernetes on AWS, if you want to use the same features on AWS, then you will go with the second option, which is called EKS, or Elastic Kubernetes Service. So these are the two orchestration options that you have. Now, irrespective of which one you go with, the actual place of running containers, where do the containers actually run? You can either run it on EC2, meaning if you want to manage everything, which is a server-based approach. We talked about Lambda and we talked about EC2, right? So if you want to manage it yourself, you can host the containers on EC2. Or if you don't want to manage it yourself, you can use a solution called Fargate, which is nothing but a hosting solution for containers in the serverless space. What do I mean by that? I don't have to worry about scaling them. I don't have to worry about how do I take care of cluster package optimization. I don't have to worry about even the virtual server, but I can run containers, and that service or feature is called AWS Fargate. So these are the different options that you have. I'm just going to reiterate all the compute services we discussed. EC2, virtual machine is called EC2. Lambda is our serverless compute solution. Elastic Container Service and Elastic Kubernetes Service, both container orchestration solution. Elastic Container Service is for Docker containers. Elastic Kubernetes Service is for Kubernetes support. You can use either one of them, but the hosting or where the actual running will happen, either it will be on EC2 or second option is it will be on Fargate, which is a serverless option. And we talked about two more services apart from compute, which is simple notification service and simple queue service. SNS is a push notification service. SQS is a queue or a buffer mechanism available. So that is your module 2. Let's quickly do a knowledge check question, folks, and then we'll take a short break. First question. A customer wants to use an EC2 instance for a batch processing workload. So something that's compute intensive. Which EC2 instance type should they use? Batch processing, meaning it is a bit of compute intensive. So which type would they use? It's an easy guess, folks. Compute intensive, and there's just one answer which matches to that. Compute optimized. Absolutely right. The answer is compute optimized. That is the answer. Second question. What are the contract length options for EC2 reserved instances? So remember when we were discussing, I told you that when you do a reservation, you can go with a reservation of 2 time periods. What are those 2 time periods? How many years? Yes, I mentioned 1 year as well as a 3-year commitment. So the answer is 1 year or 3 years. Next one, I'll call out the options. A customer has a workload that will run for a total of 6 months and can withstand interruptions. What would be the most cost-efficient EC2 instance purchasing option? That's the question. The answers are A. Reserved instance, B. Dedicated instance, C. On-demand instance, and D. Spot instance. The key phrase here is it can withstand interruptions. That is the key phrase here. So they are okay with an interruption and they want the most cost-efficient option. of these four options, the most cost efficient option is definitely spot instances. Remember, just to reiterate, spot instances are whatever spare capacity is available in the on-demand pool that is given out as spot at a much lower cost. So spot has the least cost. However, the only problem is it can be interrupted. If AWS requires the capacity back, it can be interrupted. But here in the question itself, it says they are okay with an interruption. So obviously they can go with the spot instance. Correct answer is option D. Right? Okay. So folks, that brings us to the end of the second module, which is compute. We'll take another short break. It's around 11:05. It's around 11. Let's take a break. 11:05, a 5 minutes break, and then let's be back. Okay, see you all in 5 minutes.
আমি আসছি কোথায় গাড়িটা ছেড়ে দিয়ে আসছি বড়টা ট্রেনে যদি যাই বড়টা ট্রেনে গিয়ে আসতে পারবো
হ্যাঁ আসতে পারবা লাল গোলা চারটেই
All right, folks, if you are back, please do give me a quick confirmation. Wonderful. So, folks who joined late, that's okay. So, like I said, towards the end, we will let you get registered on Skill Builder, and you will be taking the extended version of this in the form of a digital course. That is the idea. I'm here to just get you started on the journey and answer any major questions. So, don't worry, even if you joined late, you can still catch up on the digital course. Right? Okay, so we are in module 3, which is about the global infrastructure. What are the different components? What are the benefits of having these components? And how do you make this decision? Now, why is this global infrastructure important? Now, come back to our coffee shop example. Imagine there is a parade going on in front of our coffee shop. Now, all the roads to our coffee shop are blocked, and people cannot reach the coffee shop. Now, there should obviously be another branch or another outlet where these people can go and get their coffee, right? Similarly, if you think about AWS infrastructure as well, it is not just one region or one geographical location that we are talking about. There are multiple geographical locations available across the globe where you can go and deploy your architectures into, and this is called a region. And currently there are 32 regions available, and in India we have 2 regions. One is Mumbai and one is Hyderabad. Obviously there are regions outside of India. Sydney, Tokyo, Ohio, Oregon, multiple regions are there. 32 is the count right now, but there are other regions in the upcoming phase. So as a person working on cloud, on AWS, how do you decide which region will I be using? You can consider a couple of factors, like first of all, where are my customers? If my users are in India, then it makes sense to use an Indian region rather than using something in the US. So, where are my customers? That's the first category. Second category, legal requirements. So, imagine tomorrow Indian government says Indian customer data cannot be stored outside of India. Now, again, we only have 2 options, Mumbai and Hyderabad. And you might be aware of rules like GDPR, which is already imposing these kind of restrictions where you cannot store certain data outside of certain regions. So this will affect your decision. The third one, services. Not all services are available in all the regions. Especially when a new service comes out, it might be created or deployed in 1 or 2 regions and then later on into the other regions. So perhaps the service is not available everywhere. And the fourth one, pricing. Now, if you buy a coffee in New York versus you buy a coffee in, let's say, Bangalore, the price is going to be different. Same way, the price of services will also be different in different regions. It can be very minute, but there may be a difference. So these are the primary factors that you can consider. So based on these factors, you will decide which place to go and launch your resources into. So imagine I am creating an e-commerce application. The servers of this application, the load balancers, the Lambda functions, the queues, all of these, I will decide which geographical location to deploy into, and then that region is the one I will choose. So a region is the starting point of your global infrastructure when you're deploying something. There is a question, Rahul, what is the need of a region? See, Rahul, think of it like if you were in an on-premise infrastructure, where would you deploy your application? You will deploy it in your physical infrastructure. When you're on cloud, you still need the same amount of control. If your customers are, let's say, in India, and you don't have the option of choosing something which is in India, then you're going to suffer from latency problems. Or if your customers have a data protection law and you're not able to adhere to that data protection law, that is a compliance problem there. So you need to be able to decide which region you want to choose from. Okay, now within the regions, we have something called an availability zone, or in short, it's called an AZ. AZ, availability zone. Every region will have at least 2 availability zones, and these availability zones can be thought of as a group of data segments. So the hierarchy is you have regions, availability zones inside the regions, and then the availability zones will have group of data centers. So you cannot directly interact with the data center. You interact with the region and you interact with the availability zone. Now, these availability zones, I mentioned that there will be at least 2 availability zones per region. These availability zones are fault isolated. They have their own network, they have their own power connections, they are not in the same fault plane. So that if one availability zone has a problem, we should still be able to serve our application from the second availability zone. That is why at least 2 availability zones are there in every region. It can be more than 2, it can be 3, it can be 6, but minimum 2 availability zones will be there, so that you can use this concept called multi-AC deployment. Nothing but deploying the server into more than one availability zone within the same region, so that if one availability zone is down, you can still serve your traffic customers from the second availability zone. That is called a multi-AC deployment. Okay, so just to reiterate, we have regions, availability zones, and availability zones are group of data centers. So the first step towards high availability is a multi-AC deployment. And Amit has shared a document on selecting workloads. Please keep a track of that as well. Alright. Now the third concept under the global infrastructure is called an edge location. Now this is an optional thing where, for example, let's say you have your physical servers, your virtual servers, your EC2 instances deployed, let's say, in the US. Okay? But your customers are there in India, they are there in Europe, they are there in, let's say, Australia, they are there in different parts of the world. So these customers, let's imagine a customer from India trying to request for something from a server which is running in US. Imagine the latency. This is a network called. Imagine the time it takes, the latency it takes to go through these different networks from India to reach US. To bridge this latency gap, what we do is we cache the content closer to the end user location. And these caching locations are called edge locations. Edge locations. Think of them as small data centers or points of presence closer to your end user. So I told you there are 32 regions, but there are 400 plus edge locations available. 400 plus locations are available. Now what happens is certain services like CloudFront. So CloudFront is a content delivery network or a CDN service. When you use this service, what happens is CloudFront will cache the content in the edge location, and when a customer connects to the endpoint and tries to get the data, it is not connecting to the USA EC2 instance, no. Rather, they will be redirected to the nearest edge location. So if this person is in India, the edge location which is closer to their location in India, they are redirected to. If the content is available in that edge location, then it is returned immediately to the user, thus reducing the latency. Only if the content is not available, it is fetched from the actual server in US or wherever you have posted it, and then it is updated in the edge location. So edge location is a caching location, and more than 400 locations are available throughout the globe. They come into picture only when you use certain services. One of them is CloudFront. Other services like Route 53, which is a DNS service. Shield, which is a DDoS mitigation service. All these services help you with edge location. So these are the three primary global infrastructure concepts that we have. I'm just going to take a look at the chat to see if there are any questions. Folks, again, just reiterating, please ask the question not just to me, but also include Amit also in your question. Because if you ask it just to me, Amit will not be able to see it, and I will not be able to keep a track of all the questions. Okay? Okay. One more concept we'll discuss, which is outposts. Now outposts are nothing but, so remember we talked about sometimes companies having compliance requirements where they cannot move any data. Let's say government institutions, they cannot move data to cloud. So what they go with is, they go with hybrid approach, right? Where they have certain services running on premises and the certain services running on cloud. However, in this approach, the customer still has to handle the on-premise data center. So it's not a very pleasant experience for them, right? Handling the on-premise data center. Instead of this, what they can do is, if they have a regulation saying that you cannot move the data outside of your location, outside of your physical location, then you can go with this feature called outposts. Outpost is nothing but it's an infrastructure component where in your location, wherever you say your location, your data center, your retail or office location, the servers and the racks will be brought in by AWS. Pre-configured racks will be created and brought in by AWS according to your requirements. And then it is just a plug and play. So the idea is the space is yours. The components is bought in by AWS. The server, the rack, and all are bought in by AWS. And this gives you a easier way of managing hybrid. So you still get to keep the data on your physical boundary, but the management of the servers and the racks will be from AWS, and you can still use EC2, you can still use containers and the other services, but they will run on your physical location, but on these outpost racks that are brought in by AWS. So these are the different components that we have in the global infrastructure. So again, just a review: regions, geographical locations. Within the regions, we have availability zones. And then availability zones have data centers. Obviously, those data centers you cannot directly interact with. You interact with the availability zones. Edge location, an optional component for caching your content using services like CloudFront. Outposts, If you want a hybrid setup, hybrid meaning certain applications running on cloud, certain applications running on premises. However, you don't want to manage the servers, or you still want to have EC2 running, you still want to have container services running, but you cannot move your data outside of your physical location. Let's say your data center location. There will be an outpost rack created which will have servers in it, which is created by AWS, configured by AWS. It will be brought to your location, your physical location, and you can just plug and play it using, just plug in the electricity, and you can launch your EC2 and other AWS services, but it will run from your on-premise infrastructure. So the space is yours. The servers AWS will provide, but it will run on your on-premise infrastructure. That is all. Piyush, I hope that's clear. Okay, so that is your global infrastructure, folks. Let's do a quick knowledge check question. First question: which of the following is true for the global infrastructure? Option A: an availability zone consists of a single region. Option B: an availability zone consists of two or more regions. Option C: a region consists of a single availability zone. Option D: a region consists of three or more availability zones. I hope you folks remember the hierarchy. It is regions, then AZs, and then AZs consists of data centers. So this is the hierarchy. Now you can think about the answer. First option says availability zone consists of a single region. That's incorrect because it is within a region that you have an availability zone. Second option is also incorrect because it says availability zone consists of two or more regions. No, regions consist of availability zones. D is also incorrect. C: region consists of single availability zone. No, if it is single availability zone, then the high availability part is not there. So correct answer is region consists of three more availability zones. There are regions with up to 6 availability zones and more, right? So that is the correct answer. Second question: which factors should be considered when selecting a region? Two correct answers. Option A: compliance with data governance and legal requirements. Option B: proximity to your customers. Option C: access to 24/7 technical support. Option D: ability to assign customer permissions to different users. And E: access to the AWS command line interface. Now, a couple of clarifications, folks. The access to technical support, access to assign permissions to users, access to CLI, SDK, console, this does not depend on a region. Any region you choose, all of these features are available. So correct answers are option A and B: compliance with government regulations as well as proximity to the customer. So these are the two options that we have. So that was a very small module, folks, just to give you an introduction to the global infrastructure. So next time you hear a region is a geographical location. Within a region, you have availability zones, and availability zones have data centers, which you don't interact with, you interact with the availability zone. So multi-AC deployment is the first step towards high availability. So, because it was a small module, we are not going to take a break. We will go through the next module and then we will take a break. We hardly took 15 to 20 minutes. The next module is about networking. Here we are going to talk about basic networking concepts, VPN, direct connect, firewall strategies. All of this we will look at. Let's talk about the coffee shop again. As a customer, you can go to the cashier. That is a public space. But you cannot go to the kitchen. That is a private space. So there is a segregation. There is a division between a public space as well as a private space which is not directly accessible. The same thing you can do on AWS using a networking concept called Amazon Virtual Private Cloud or Amazon VPC. So VPC is a networking concept which is a private network that you can create in your AWS account, and you can decide that in this VPC I can create my EC2 instances, I can create my load balancers, I can create my auto-scaling groups. So all my resources I can put in the VPC. And this VPC, similar to how we talked about having a public space and having a private space in the coffee shop, in the VPC also you can divide the big network into small sub-networks which are called subnets. VPC divided into subnets. And these subnets can be public subnet or private subnet. Difference is public subnet is accessible from the internet. Private subnet does not have direct internet access. So public subnet has direct internet access. Private subnet does not have direct internet access. So how does this public subnet get a direct internet access? It uses a virtual device. We are in the cloud space, so everything is virtual. For a public subnet to get access to the internet, it uses a virtual device which is called Internet Gateway, or in short, it's also called IGW, Internet Gateway. This is how a public subnet gets access to the internet. Now, there was a question on the chat. How is VPC different from VPN? VPN is virtual private network. So when would you use a VPN? We talked about hybrid setups, certain applications running on cloud, certain applications running on premises. Imagine that is the case here. Now, I want to connect the on-premises data center with AWS Cloud. I want to connect them. What is one way to connect? I can use the internet. But we know that plain internet is not safe. Security concerns are there. So the second option is we go with VPN, or it's also called the site-to-site VPN. Why is it called that? It's connecting one site to the other. It's connecting AWS to your on-premise network. So this is nothing but on top of your internet connection. It is still internet. On top of that, you have an encrypted connection, which is your VPN. So the site-to-site VPN that AWS supports, it is an IPsec tunnel mode VPN. And for creating this VPN, we need a device on the AWS side. So we talked about internet gateway. Internet gateway is for internet access. Now for VPN access, we need a separate device, and that device is called Virtual Private Gateway, or VGW, Virtual Private Gateway. So internet gateway, internet access, virtual private gateway lets you set up a VPN. So I hope it's clear what is VPC and what is VPN. VPC is the name for the private network on the cloud. That can be divided into public and private subnets. Public subnet uses the internet gateway to connect to the internet. That is VPC. VPN, on the other hand, it is used to connect two hybrid networks on premises and cloud by creating an encrypted connection on the existing internet connection. There's one more concept which is called direct connect. Now, when you use VPN, it is still the internet. You're using the internet, but you get a secure connection on top of it. So if the internet has a downtime, if the provider has a problem, you may suffer. And there will be bandwidth issues as well. In such situations, for organizations that require huge amount of dedicated bandwidth on a daily usage purpose, this is where direct connect comes into picture. Direct connect means there is no internet in use. Here you are going to set up a fiber optic connectivity. An Ethernet physical cable is going to be set up between your on-premises and between your AWS region. So instead of relying on the internet, here you're using a physical fiber optic cable. But like I said, it is not for daily use. It is for, when I say daily use, it is not for a one-time use or one-time data transfer or some amount of data transfer. It is when every other day you have GBs of data to transfer. You cannot rely on the internet. You want GBs of data to transfer every other day, then you will go direct connect. One-time data transfer, you don't have to go with direct connect. Now, one question might be, how do I connect AWS at my data center? I don't know where AWS data centers are. Physically, I don't know. So what happens is, there are these locations available across the globe, which are called direct connect locations, where AWS has already partnered and created a connection between AWS and these locations. All you need to do is you need to go through a direct connect partner and set up the connection between your location and this direct connect location. And now you have a physical connectivity. So just to recap, VPC, the private cloud network, VPN, on top of the internet you're getting an encrypted connection to connect hybrid cloud. Direct connect, no use of the internet, physical connectivity between on-premises and AWS. Now let's talk a little bit on the security side of things in a VPC. There are two types of firewalls that you will use in a VPC. One is called Network Access Control List, or NACL, and the other is called Security Group. Okay. Now, imagine this example of a coffee shop itself. Now, imagine this coffee shop is situated in a shopping complex or a shopping mall. So there is a parking area. When you enter the shopping mall, you have to get a parking ticket. So there is check number 1. Enter. When you exit the shopping mall, there is a payment. You have to show the parking ticket. That is exit check. So this kind of check, this kind of filtering, if you apply to firewalls, where there is a check for inbound as well as there is a check for outbound, this is called stateful packet filtering, meaning both the inbound as well as the outbound traffic is analyzed and there are rules to decide both inbound as well as outbound. Stateful. Remember the parking example. Now, you go to the coffee shop, you buy the coffee. Perhaps when you enter the coffee shop, no one is checking, but when you exit, someone is checking your receipt. So there is only one check here, either inbound or outbound. So the place or the kind of filtering where only one kind of check happens. So just to give you a reiteration again, stateful versus stateless. Stateful versus stateless. When the inbound as well as the outbound is checked. When the inbound as well as the outbound is monitored. When both has to be monitored, meaning it cannot remember the state. That is stateless. Only the inbound needs to be checked or only the outbound needs to be checked. That is stateful. So parking lot example, think of that as stateless. The coffee shop example, think of that as stateful. Apply this to firewalls. NACL is a stateless firewall, meaning it cannot remember any states. Both inbound and outbound it has to check. When a traffic comes into the network, when the network access control list firewall is used, the inbound has to be checked, and when the traffic goes out, the outbound has to be checked. So it cannot remember the state, and hence it is a stateless firewall. It cannot remember the state. Security group, on the other hand, is a stateful firewall. It can remember. So think of the coffee shop example. If the inbound is checked, then the outbound doesn't have to be checked because it can remember the connection. Or vice versa. If the outbound is checked, it does not have to check the inbound because it can remember the connection. So stateful firewall, security group, stateless firewall, NACL. And one more thing, security groups, they work at the server level, so at the EC2 level. NACLs, on the other hand, they work at the subnet level. Reiterating, security groups work at the EC2 level, NACLs work at the subnet level. Security groups are stateful firewalls, so they can remember the traffic, either check inbound or outbound. NACLs are stateless firewalls. They cannot remember the traffic, so both inbound as well as outbound has to be checked. So I hope that's clear, folks. Any questions between NACL and security group? Security group, stateful, NACL, stateless. Okay, I don't see any questions on the chat. Okay. Let's talk about a few more services. We need a DNS endpoint. Why do you need a DNS endpoint? EC2 instances have IP addresses, and or probably you might have public DNS endpoints which are not very friendly. I want a friendly DNS name because as a customer, when I go to the browser, I will type www.whatever is my website endpoint.com or .in. I need a DNS name. And then the DNS server has to go and get the IP address, which is the DNS name lookup. And then I am redirected to that particular endpoint. Which AWS service can handle this? The service is called Amazon Route 53. So Route 53 is the DNS service on AWS where you can import your domain names, you can purchase domain names, and you can create records in Route 53. When I say records, what I mean by that is, for example, if I have www.example.com, what should that redirect to? Which IP address should that redirect to? These kind of records I can create using Route 53. So whenever someone uses your DNS endpoint and looks up that DNS endpoint, Route 53 identify that company's corresponding IP address, and this information is sent back by Route 53 to the caller. So in this case, in this architecture that is being shown, you can see that there is a couple of EC2 instances. In front of that, there is a load balancer. In front of that, there is CloudFront. Why CloudFront? Caching. We talked about caching. So as a user, I will not know the application load balancers and DNS name. I will not know CloudFront DNS. I will only know the company ID or the website ID or the website DNS. So whenever I go and type www.whatever is the endpoint.com, Route 53 is responsible for looking at the record, saying that, okay, so this endpoint means you have to talk to this particular CloudFront endpoint. It is the Route 53 service's responsibility, and so Route 53 will handle the DNS resolution. This is what is Route 53. Okay, so folks, let's do a quick knowledge check. Question number 1. Which component or service can be used to establish a private, dedicated connection between a company's data center and AWS? Options are